Welcome to this full-stack AI automation tutorial. In this video, we will walk through building and deploying an autonomous AI agent pipeline, moving from local Python code all the way to an automated cloud CI/CD deployment. This tutorial covers 4 core pillars: creating a real-world autonomous agent, wrapping it in a high-performance FastAPI Webhook API, containerizing the application with Docker, and establishing a robust GitHub CI/CD pipeline for automated deployment. Why move beyond traditional scripts? Traditional automation relies on rigid rules that often break when inputs change. By contrast, autonomous AI agents use natural language reasoning to handle messy, real-world data and can self-correct when errors occur, significantly reducing manual work. Our AI agent follows a precise execution loop. It perceives the request, reasons about the necessary actions, executes the required tools, and finally validates the output. Remember, this is an autonomous software worker, not just a simple chatbot. The end-to-end architecture begins with an inbound trigger, passes through our FastAPI gateway where the AI agent processes the task using its reasoning loop, before finally deploying the container to the cloud via GitHub Actions. Our technology stack includes Python 3.12, FastAPI for our web interface, Docker for reliable containerization, Google Cloud Run for scalable execution, and GitHub Actions for continuous integration and deployment. To get started, ensure you have Python 3.11 or newer, Docker Desktop, and a Git environment installed. You will also need an LLM API key, a Google Cloud account with Cloud Run permissions, and a GitHub repository. Here is our roadmap. We will spend the next 15 minutes covering agent development, the FastAPI engine, containerization, setting up our CI/CD pipeline, and finally, monitoring and production operations. In Module 2, we dive into the core of our project, building the Python AI agent, defining our custom tools, setting up the LLM execution loop, and writing our local tests. Begin by setting up your project directory and a virtual environment to isolate dependencies. It is a best practice to pin your requirements and keep your sensitive API keys inside a .env file, which you should immediately add to your gitignore. Good file organization is essential. Notice how we separate our agent logic from the FastAPI transport layer. This modularity makes our tools easier to test independently and keeps the codebase clean for future CI/CD integration. Custom agent tools are just normal Python functions. The LLM uses your doc strings to understand when and how to call them. Always ensure your tools return structured data, like JSON, so the agent can parse it easily. When defining your tool schema for function calling, remember that the LLM does not execute your code directly. It simply returns a structured JSON object. Your local Python runtime is responsible for parsing that request and executing the logic. Your execution loop is the heart of the agent. By using a system prompt, you define the agent's behavior. The loop continues until the model determines that no further tool calls are required to reach a final resolution. Finally, security is paramount. Never execute arbitrary code strings from an LLM. Use an explicit whitelist for allowed tools, validate all incoming JSON arguments, and wrap every call in a try-except block to handle potential errors gracefully. In this section, we cover managing state and conversation history. This includes maintaining short-term context through message arrays, implementing token budgeting to control costs, and using external persistence for long-term historical context. Production resilience requires handling rate limits and API failures. Using libraries like Tenacity, you can implement exponential backoff, define explicit timeouts, and build graceful fallback patterns to ensure your background webhooks never hang indefinitely. It is critical to verify your agent locally. Use a Python CLI test run to confirm your agent correctly processes inputs, invokes the intended tools, and produces the expected output within reasonable time limits. Always review your terminal output carefully. You should see the agent initializing, selecting the correct tools, and generating a structured final triage report that identifies the root cause, suggested actions, and the overall priority. Now we transition to Module 3, building the automation API with FastAPI. This module focuses on creating REST endpoints, handling asynchronous background queues, enforcing webhook security, and implementing service health checks. A dedicated automation API is necessary for event ingestion. It allows us to receive webhooks from platforms like GitHub or Slack, provision on blocking responses, and maintain standardized security protocols across all incoming triggers. Pydantic is our tool of choice for data schemas. By defining our models up front, we gain automatic data validation, built-in error handling for malformed requests, and the ability to generate interactive OpenAPI documentation effortlessly. Here is our FastAPI webhook receiver. Notice how we use FastAPI's background tasks to offload intensive agent reasoning, which keeps our HTTP endpoint responsive even when complex processing is underway. Understanding background task processing is key. First, the webhook arrives. Next, we send an instant acknowledgement. And finally, our background worker processes the logic without delaying the original event sender. Securing your endpoint with API key verification prevents unauthorized access and protects your token budget. We utilize dependency injection to ensure that every request is authenticated against a secure environment variable. Running your API locally with Unicorn allows for rapid development. You can leverage the live reload feature and use the interactive Swagger documentation at the docs endpoint to test your routes in real time. You can easily verify your setup by sending a real webhook payload using URL from your terminal. This confirms that your API correctly receives, validates, and queues the job as intended. For robust CICD, we write PyTest unit tests. These tests validate our health check and payload parsing logic, serving as a critical safety gate that catches regressions before any code is deployed to production. In Module 4, we move on to containerizing our application with Docker. We will explore how to write efficient Docker files, optimize builds for production, and manage secrets in a containerized environment. Docker is essential for AI workflows. It eliminates environment inconsistencies, ensures portability across various cloud platforms, and provides the scalability required to handle bursts of incoming webhooks in production. Now let's write our Production Dockerfile. We use a slim Python image to keep our footprint small and fast. By copying our requirements files separately before the rest of the code, we leverage Docker's layer caching to speed up builds significantly. Don't forget the .docker ignore file. It is a critical security step to ensure your local environment files, Git metadata, and sensitive .env secrets are never baked into the container image. This keeps your image secure and lean. Building the image locally is straightforward. Use the docker build command with a descriptive tag. This process creates immutable layers that can be pushed to any container registry, ensuring the exact same code runs in development and production. To run your container, use the docker run command and inject your API keys as environment variables at runtime. This practice keeps your image clean and allows you to swap configurations without rebuilding the application. In Module 5, we will automate everything with GitHub Actions. We'll set up a continuous integration and deployment pipeline that builds, tests, and deploys our agent every time we push code to the repository. Automating your deployment is a force multiplier for AI engineering. It removes the risk of manual configuration errors, enforces consistent quality gates through automated tests, and provides an immutable audit trail for every single deployment. Our automated pipeline consists of 5 stages: triggering on a Git push, executing our PyTest suite, authenticating with Google Cloud, building and pushing the container image, and finally deploying to Cloud Run. Before you automate, you must set up a Google Cloud Service account. Always apply the principle of least privilege, granting only the specific permissions needed for building images and managing the Cloud Run service. Manage your sensitive keys by storing them in your GitHub repository secrets. This ensures that while your workflow has access to your cloud project and API keys, your sensitive credentials remain encrypted and hidden from the repository code. Our workflow configuration starts by defining the trigger on the main branch. The initial jobs focus on checking out the code, setting up the Python environment, and running your test suite to ensure the agent logic is sound. After the tests pass, the pipeline proceeds to authentication and deployment. We configure the Docker client to talk to the Google Artifact Registry, build the tagged image, and deploy it directly to the Cloud Run environment. Triggering the deployment is as simple as pushing a new commit. Every JIT push to the main branch initializes the workflow, allowing you to see your changes reflected in your cloud environment in under a minute. Monitor your deployment progress directly in the GitHub Actions tab. Each step provides detailed logs, making it simple to verify that your test passed and your container was successfully deployed to your cloud endpoint. Finally, perform a smoke test. Use curl to ping your live production URL. Verify the health endpoint and run a sample triage request to ensure the agent is fully operational in its new cloud home. We have successfully built and deployed an autonomous AI agent. In our final module, we will explore production operations, including cloud logging, monitoring, and strategies for managing token usage and scale. In this video, we'll look at how to inspect your real-time Cloud Run logs. You can use the gcloud CLI tool to tail the logs from your deployed AI agent pipeline, allowing you to monitor execution steps, tool invocations, and agent decisions as they happen in production. To optimize costs for your AI pipelines, consider these 3 strategies. Leverage Cloud Run's ability to scale to 0. Select appropriate model tiers based on complexity, and implement caching and deduplication to avoid redundant LLM calls. Security is paramount in production. Ensure HTTPS is used for all endpoints. Avoid hard-coding secrets in your repository. Implement strict sandboxing for tools, and protect your system against prompt injection by treating inputs as data parameters. Be aware of common pitfalls. Prevent infinite tool loops by setting iteration limits. Avoid blocking the main thread by using asynchronous background tasks, and ensure stable deployments by pinning exact dependency versions in your requirements file. Once your core agent is running, you can extend its capabilities. Explore building automated PR reviewers, autonomous database healers, multimodal support agents, or interactive bots that allow for human-in-the-loop approvals via platforms like Slack. For advanced production operations, utilize canary deployments. This approach lets you safely shift a small percentage of traffic to a new revision for testing, providing a native, zero-downtime way to roll out updates and perform instant rollbacks. To summarize the architecture, we have an ingestion phase using FastAPI, an execution phase for agent logic, containerized packaging for consistency, and an automated CICD pipeline for rapid deployments. The key takeaways are: treat agent logic as code, separate your architecture concerns, use containers to ensure environment parity, and leverage CICD to maintain high development velocity. Follow this 4-step plan to get started in 5 minutes. Clone the starter repository, define your specific tools, configure your GitHub secrets for deployment, and push your code to initiate an automated rollout. You can access the full starter code in the linked GitHub repository, which includes pre-configured workflows, test suites, and all the necessary infrastructure files to help you deploy your own agent quickly. Thanks for watching. If this tutorial helped you, please like the video, subscribe for more content, and join our Discord community to share what you're building next.